4 billion miles away from Earth, floating in the endless black of deep space, sits a tiny frozen ball of rock and ice that should be completely lifeless and inert. It has no weather systems, no gusts of wind, no dynamic changes or unexpected phenomena of any kind. For eons, it seemed nothing more than a quiet, dormant lump of ice, drifting silently in the eternal darkness of the outer solar system. Yet in recent years, scientists have made a mind-blowing discovery about this distant little world, one that sounds far too strange to be real. Against all logical expectations, Pluto can cool itself down actively, using nothing but the thin, hazy atmosphere that wraps around its surface. Far beyond every familiar planet in our solar system lies this bizarre celestial body, whose actual temperature is far colder than every mathematical model and astronomical calculation once predicted. For decades, seasoned astronomers and physicists dismissed this strange cooling effect as impossible, nothing more than a flawed hypothesis. But when the powerful James Webb Space Telescope focused its ultra-precise instruments directly on Pluto, it finally confirmed that this seemingly ridiculous cosmic phenomenon is 100% real. This is the incredible untold story of Pluto, the tiny world that was once beloved as the ninth planet of our solar system, only to be stripped of its planetary status and written off as a boring, dead dwarf planet before shocking the entire scientific community with its hidden secrets. Stick with me through this entire story, and you'll fully understand exactly how an icy sphere smaller than Earth's moon can run its own natural cosmic refrigeration system. More importantly, you'll learn why this bizarre physical quirk might hold crucial clues to understanding the fundamental building blocks and potential origins of life across the universe. Let's start right at the very beginning, with the humble discovery of this extraordinary distant world. Back in 1930, a young astronomer named Clyde Tombaugh worked tirelessly at a small observatory in Arizona, spending countless hours poring over thousands of photographic plates capturing the night sky. His job was monotonous and extremely repetitive by design. Night after night, he carefully compared sky images taken at different times, scanning painstakingly for a single tiny dot of light that shifted position relative to the fixed background stars. For weeks and months, he found nothing at all, no movement, no new objects, no surprises. Then one day, his patience paid off. A faint, tiny speck of light had drifted slightly across the frame, standing out from the stationary stars surrounding it. That faint speck was Pluto. For the next 76 years, generations of children across the globe grew up learning that Pluto was the official ninth planet of our solar system, a staple of every astronomy textbook and classroom lesson. Everything changed in 2006, when an international panel of leading scientists gathered to establish strict, standardized criteria to define what officially qualifies as a planet. After careful evaluation, Pluto failed to meet the new planetary rules and lost its long-held title. It was reclassified as a dwarf planet, a lesser-known category of celestial bodies. The news sparked widespread disappointment and even public frustration worldwide. To millions of people, it felt as though Pluto had been unfairly kicked out of the planetary family it had belonged to in humanity's collective memory for nearly a century. But here's the most surprising twist of all. This controversial demotion never turned Pluto into a boring, irrelevant relic of space. On the contrary, it cleared the way for one of the most shocking, mind-bending discoveries in the entire history of solar system astronomy. A world everyone wrote off as dead and dull turned out to be far more complex and dynamic than any scientist ever imagined. To fully appreciate how groundbreaking these new findings are, you have to understand just how little we knew about Pluto for nearly all of the 20th century. Even with the most powerful ground-based telescopes humanity had built, Pluto appeared as nothing more than a blurry, indistinct smudge of faint light in the distant sky. We could not measure its exact size and mass, could not make out any surface terrain or geological features, and had no conclusive proof whether it possessed any atmosphere whatsoever. Every theory, every assumption, and every detail we thought we knew about Pluto was little more than a guess, stacked on top of another unproven speculation. Let's put Pluto's tiny scale and extreme distance into clear perspective. If we scaled Earth down to the size of a standard basketball, Pluto would be smaller than a single golf ball. This minuscule icy world orbits the Sun at a distance roughly 40 times farther than Earth's orbit. Out in this remote corner of the solar system, sunlight is incredibly weak and diffused. Standing on Pluto's surface at its brightest midday would feel dimmer and darker than the deep twilight we experience here on Earth after sunset, and the cold that dominates this distant world is almost impossible for the human mind to comprehend. Pluto's average surface temperature hovers around negative 380 degrees Fahrenheit. That's more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth, even in our planet's frozen polar regions. Under these extreme frigid conditions, nitrogen, the colorless, odorless gas that makes up most of the air we breathe every single day, freezes completely solid, turning into a hard, stone-like icy solid. Naturally, no scientist was ever surprised to find that Pluto is unbelievably cold. Its extreme distance from the Sun guaranteed a frozen, hostile environment. The real game-changing surprise is that Pluto is even colder than our most extreme and conservative scientific models predicted. Some invisible, unknown mechanism was actively dragging its temperature far lower than the natural baseline for its position in the solar system. For more than a decade, the scientific community had no viable explanation for this bizarre cooling anomaly. The first real breakthrough, the first meaningful clue to solve this cosmic mystery, arrived in 2015. After decades of distant observation and endless speculation, a human-made space probe finally traveled close enough to capture clear, high-resolution observations of Pluto up close. The data it sent back completely overturned every long-standing scientific belief about this tiny dwarf planet, and it's where our incredible story truly begins to unfold. Before we dive deeper into Pluto's wild hidden science, a quick favor. If you love hearing mind-blowing verified space discoveries, real peer-reviewed scientific findings, not fictional clickbait stories, make sure to hit the subscribe button right now. This channel is dedicated to sharing genuine, groundbreaking astronomical discoveries that rewrite what we know about our universe. And I promise you the secrets we'll cover next about Pluto's largest moon and the bizarre, intimate cosmic relationship between these two frozen worlds are even stranger and more fascinating than anything we've covered so far. You absolutely do not want to miss this one-of-a-kind space story. All right, let's keep exploring. That historic first close-up flyby was only the very beginning of Pluto's endless list of mysteries. In July of 2015, after traveling non-stop through the vacuum of deep space for nearly 10 years, NASA's New Horizons spacecraft finally reached its long-awaited target, Pluto. This mission had zero room for error. The probe was traveling at an extreme speed of over 30,000 miles per hour, with no ability to slow down, hover, turn around, or make a second pass. It had only a few precious minutes to scan, photograph, and collect every possible data point before racing past Pluto forever, shooting deeper into the uncharted darkness of the outer solar system. What New Horizons sent back to Earth completely shattered the outdated, blurry image scientists had held of Pluto for generations. Stretching across Pluto's surface was a vast, pale, smooth landmass shaped almost perfectly like a giant heart. This iconic heart plane looked surprisingly pristine and geologically young, standing in stark contrast to the ancient, battered landscape surrounding it, an area covered in countless craters from billions of years of cosmic impacts. Just nearby, towering mountains rose more than 10,000 feet into Pluto's dark sky, entirely composed of pure water ice. At Pluto's extreme sub-zero temperatures, water ice doesn't behave like the soft, slippery ice we know on Earth. It hardens into an ultra-dense, rigid material similar to solid bedrock, so tough that striking it would produce a sharp, metallic ring. But the most shocking and unexpected discovery of the entire flyby wasn't on Pluto's surface at all. It was floating high above it. Layer upon layer of delicate, faint blue hazes extended hundreds of miles upward from the dwarf planet's surface, forming a thin, layered atmosphere. When sunlight backlit these hazy layers, they glowed with a soft, ethereal blue light, creating a stunning celestial phenomenon no one predicted. Scientists had always written Pluto off as a dead, airless, frozen rock, far too small and cold to sustain any active atmospheric features. Yet here was clear proof of a complex, layered sky surrounding this tiny world. At the time of the flyby, scientists couldn't crack the mystery of this strange haze. They had no idea if these floating atmospheric layers were completely passive, just drifting aimlessly with no real purpose, or if they were actively responsible for Pluto's unexplained extreme cooling. New Horizons simply didn't have the tools to answer this critical question. After capturing its once-in-a-lifetime data, the probe continued speeding into deep space, never to return. All the hidden secrets locked within Pluto's mysterious blue haze remained trapped in the darkness, waiting for humanity to develop a more powerful way to study this distant world. Basic photographs could only show us what Pluto looked like. They couldn't reveal the chemical makeup of its haze, nor explain how the atmosphere interacted with the dwarf planet's surface and temperature. Scientists needed a revolutionary tool, one that could analyze the delicate chemistry of Pluto's sky from billions of miles away without launching another costly deep space mission. That game-changing tool already existed in development, but it wasn't fully operational when New Horizons completed its flyby. Once this powerful new telescope finally turned its advanced gaze on Pluto, every old assumption about its atmosphere was completely overturned. This new era of Pluto research works entirely differently from the old flyby missions. New Horizons functioned like a high-speed camera, snapping rapid photos as it raced past its target. The James Webb Space Telescope operates on a far more advanced level. Instead of just capturing images, it dissects incoming light from distant celestial bodies, much like a household prism splits plain sunlight into a full rainbow spectrum of color. By analyzing this light spectrum in extreme detail, Webb can precisely identify the exact chemical composition of distant atmospheres and surfaces, all from the comfort of Earth's local solar neighborhood. To put its power in simple terms, imagine being able to tell exactly what someone ate for breakfast just by analyzing the faint particles in their breath from across an entire room. That's the superhuman ability of the Webb telescope, except it performs this feat on faint light bouncing off a tiny frozen world 4 billion miles from Earth. For years, scientists faced a major roadblock in studying Pluto's atmosphere. Pluto and its largest moon Charon sit extremely close together in our line of sight from Earth. Older telescopes lacked the precision to separate their overlapping light signals. It's the cosmic equivalent of trying to hear a quiet whisper from one person while standing right next to someone shouting at the top of their lungs. Researchers spent years attempting to isolate a clear, pure signal from Pluto's haze alone, only to have their data completely overwhelmed and drowned out by Charon's brighter light. Time and time again, their efforts came up empty. That all changed in 2022, when Webb's ultra-sensitive instruments achieved unprecedented precision, successfully untangling the overlapping light signals of Pluto and Charon. For the very first time in human history, scientists could observe and analyze Pluto completely independently of its moon. What they discovered validated a bold, controversial hypothesis that a lone scientist had proposed years earlier, an idea almost the entire astronomical community had dismissed as impossible. Back in 2017, researcher Xi Zhang put forward a counterintuitive theory that defied every basic rule of atmospheric physics we know on Earth. On our planet, atmospheric haze and cloud layers act like an insulating blanket, trapping heat near the surface and keeping our world warm. Zhang proposed that Pluto's blue haze does the exact opposite. He theorized that these delicate atmospheric particles absorb the tiny amount of solar radiation that reaches Pluto's distant orbit, then immediately radiate that heat straight out into empty space at an extremely rapid rate, far faster than Pluto's thin atmosphere could ever retain it. Rather than insulating the frozen surface, Pluto's haze acts like a natural cosmic radiator, actively bleeding away what little heat the dwarf planet manages to capture. At the time, nearly all scientists wrote this idea off as overly speculative and impossible to prove, with no technology available to test it. All doubt was erased in 2025. A research team led by astronomer Tanguy Bertrand used the Webb telescope's unmatched resolution to conduct direct, precise measurements of Pluto's upper atmosphere. Their official findings, published that June, matched Zhang's radical theory almost perfectly. Scientists confirmed that Pluto's floating haze particles actively cool its upper sky, driving its overall temperature roughly 30 degrees lower than every previous computer model had predicted. Take a moment to let that sink in. Pluto isn't just cold because it's far away from the sun. In a very real, active sense, this tiny dwarf planet refrigerates itself intentionally, using nothing but the natural haze in its own atmosphere. Astronomers now classify this as an entirely unique type of climate system, one that has never been observed or documented on any other planet or moon in our entire solar system. This groundbreaking discovery opens up a universe of new questions. If a tiny, frozen, distant dwarf planet can manipulate its own atmosphere to cool itself down, what other bizarre, unrecognized phenomena are happening on the countless hazy, icy worlds scattered throughout the uncharted outer solar system? How many other hidden cosmic tricks have we completely missed until now? But Pluto's self-cooling haze holds one more incredible secret, a secret that connects this tiny dwarf planet to its moon, creating one of the most unusual and intimate cosmic relationships between two celestial bodies we've ever discovered. For billions of years, Pluto has been slowly and steadily leaking its atmosphere out into deep space. Thin gaseous particles from its fragile sky drift upward, escape Pluto's weak gravitational pull, and float away into the surrounding darkness. Scientists had long known this atmospheric leakage was happening, but for decades, they had no idea where all those escaping gas particles were going. The gas wasn't just vanishing into thin air, it was being captured, trapped, and repurposed by something right beside Pluto. That something is Charon, Pluto's largest and closest moon. A heavily cratered frozen ice world, Charon orbits extremely near Pluto, locked in a tight gravitational tidal dance with its host planet. The two bodies are permanently tidally locked, always facing each other as they race around the sun together. Most of Charon's surface is plain, gray water ice, pockmarked with billions of years of impact craters, except for its two polar regions. Both the north and south poles of Charon are stained with a deep, rich, reddish-brown hue, far darker than any other terrain on the entire moon. For decades, scientists strongly suspected this strange polar discoloration was somehow linked to Pluto's atmospheric leakage, but they had no concrete proof to confirm the connection. Today we finally have the full picture, and it's absolutely extraordinary. Thanks to Charon's unique orbital tilt, its north pole spends decades at a time plunged in complete, total darkness. No sunlight whatsoever reaches this polar region during these long, dark cycles, turning it into the perfect cold trap for floating cosmic gases. The tiny atmospheric particles escaping Pluto drift across the short distance between the two worlds, freeze solid the second they touch Charon's shadowed polar surface, and pile up in thick frozen layers over decades and centuries. When the orbit finally shifts and sunlight returns to Charon's frozen pole after decades of darkness, something incredible happens. These frozen Pluto gas deposits don't simply melt and float away as you'd expect. Instead, harsh solar radiation and constant cosmic ray bombardment smash apart the frozen gas molecules, rearranging their atomic structure and fusing the broken fragments into new, heavy, reddish-brown chemical compounds. This newly formed material is completely stable and non-volatile. It never evaporates back into space. It locks permanently into Charon's surface, darkening those iconic polar stains a little more with every single orbital cycle. Two completely separate frozen worlds, bound by gravity for billions of years, have been engaged in a slow, silent cosmic trade. Pluto continuously sheds pieces of its own atmosphere, while Charon catches those drifting particles and transforms them into permanent color on its surface. This ancient exchange has been ongoing far longer than human civilization has existed, long before we ever named either Pluto or Charon. As if that bizarre relationship wasn't enough, Charon still had one more major surprise for scientists. In 2024, a research team led by Sylvia Protopapa used the Webb telescope to conduct an ultra-detailed scan of Charon's surface. For the first time in history, they confirmed the presence of complex frozen chemical deposits no one had ever proven existed on the Moon before. Locked into Charon's icy surface are frozen carbon dioxide, the exact gas humans and animals exhale with every breath, and hydrogen peroxide, the same compound we use to clean and disinfect minor wounds on Earth. Scientists determined the carbon dioxide most likely comes from ancient underground layers on Charon, unearthed and exposed by massive asteroid impacts billions of years ago. The hydrogen peroxide forms slowly over millions of years, as constant cosmic radiation bombards Charon's native water ice, breaking down and rearranging its molecular structure into an entirely new substance. Just when researchers thought Charon was nothing more than a boring, geologically dead ice sphere, it revealed stunning chemical complexity that no one anticipated. So to recap everything we've uncovered so far, Pluto actively cools its own atmosphere using floating blue haze particles. That same haze slowly leaks into space, drifts to Charon, and permanently dyes the Moon's poles a deep red. These two frozen, distant worlds are gravitationally intertwined, continuously trading fragments of each other across billions of years of cosmic time. Yet even with all these incredible discoveries, Pluto still hides deeper, more baffling mysteries beneath its icy surface, and this final chapter might be the strangest and most thought-provoking part of its entire story. Let's return to Pluto's surface, and the one-of-a-kind geological features New Horizons captured on camera, formations found nowhere else in our entire solar system. In a rugged region astronomers named Tartarus Dorsa, endless rows of tall, jagged ice blades stretch across the terrain. Some of these sharp spires tower more than 1,500 feet high, and every single one is carved entirely from frozen methane gas. On Earth, tiny versions of these ice blades exist in a handful of high-altitude mountain deserts, but they never grow taller than an average human. On Pluto, the exact same natural process plays out on a colossal scale, amplified over billions of years of uninterrupted formation. A 2025 reanalysis of New Horizons' original data revealed an even more stunning detail. These giant methane ice blades cover up to 60% of Pluto's equator, forming a jagged, frozen ring of sharp spires that wraps entirely around the tiny dwarf planet. Not far from Pluto's famous heart-shaped plain stand two enormous, unexplained mountain peaks that continue to baffle geologists. One mountain rises roughly 13,000 feet above the surface, while the second climbs nearly 20,000 feet high, with a base width large enough to rival some of the biggest volcanoes on planet Earth. Both peaks feature deep depressions at their summits, surrounded by cracked, lumpy slopes that look identical to cooled, solidified lava flows. But Pluto has no molten rock, no magma, and no traditional volcanic activity. Scientists have only one viable explanation. These are cryovolcanoes, or ice volcanoes. In the distant past, these massive formations erupted thick, slushy mixtures of water, ammonia, and methane ice, pushing the frigid liquid slurry up from deep beneath Pluto's frozen outer crust. This ancient icy volcanic activity reshaped Pluto's surface entirely. This leads us to the single biggest, most revolutionary question surrounding Pluto today. If the dwarf planet once harbored enough subsurface heat to push liquid slurry miles upward through solid ice, could that subsurface warmth still exist right now, deep beneath its surface? Astronomers strongly believe it's possible, even likely, that Pluto hides a vast liquid ocean roughly 100 miles beneath its icy outer shell. This hidden ocean is prevented from freezing solid by residual thermal heat slowly leaking out of Pluto's rocky core. We don't have direct photographic proof of this ocean, but we have overwhelming geological evidence. The network of cracks and fractures stretching across Pluto's surface align perfectly with the patterns you'd expect if a layer of shifting liquid water existed just below the ice. Most tellingly, the iconic heart-shaped plain sits directly above a dense subsurface mass, exactly where a liquid ocean's pressure would push upward from below. If this hidden subsurface ocean truly exists, it has been completely sealed off from sunlight for billions of years, trapped under crushing, extreme pressure, with only tiny amounts of surface material seeping down through ice cracks to replenish it. This would make Pluto's dark, isolated ocean one of the most unique and extreme habitats in our solar system, a place where the basic chemical ingredients for life exist, completely cut off from all stellar light and solar energy. One final piece of the puzzle ties every one of Pluto's secrets together perfectly. The faint, distant sunlight that reaches Pluto is powerful enough to break apart methane molecules high in its atmosphere. These broken molecular fragments don't simply disappear. Over time, they slowly recombine into heavy, reddish-brown organic particles that drift downward and settle across Pluto's entire surface. These exact same organic compounds are believed to have rained down on early Earth billions of years ago, delivering the critical raw chemical building blocks that allowed life to first form and evolve on our planet. On Pluto, this exact life precursor cycle has run steadily and continuously for roughly 4 billion years. A slow, endless snowfall of organic life-building molecules drifts down onto the dwarf planet's surface, landing on a world far too cold and hostile to ever let those ingredients spark into life. This is the true reality of Pluto. It was never the dead, static, boring, frozen rock everyone wrote off after its 2006 planetary demotion. Instead, it's one of the most dynamic, chemically complex, scientifically rich worlds in our solar system, opening up endless new questions for astronomers and astrobiologists alike. Pluto resides deep within the Kuiper Belt, a vast, largely uncharted region of space filled with hundreds of thousands of icy dwarf planets and cosmic bodies we have barely begun to study. If this small, overlooked, formerly dismissed dwarf planet can host a self-cooling atmosphere, a chemically active moon that steals its air, ancient ice volcanoes, and a potentially habitable hidden ocean, imagine how many more incredible, undiscovered secrets are waiting for us in the dark, uncharted corners of our solar system. If this wild cosmic story blew your mind, do me a favor and hit the like button below. Subscribe to the channel if you're new, and turn on notification alerts so you never miss our next real, verified space discovery breakdown. I've got plenty more bizarre, mind-blowing true space stories coming your way. Before you go, I want to hear your personal theories. If a liquid ocean is truly locked beneath Pluto's icy crust, sealed in total darkness for billions of years, what do you think could exist down there? Do you believe it's just plain, lifeless water, or could there be something far more surprising hidden in that dark abyss? Drop your thoughts and theories in the comments below. I read every single comment personally. And if you loved this deep dive into Pluto's secrets, check out the linked video on Europa's hidden subsurface ocean. It might just be even stranger and more fascinating than Pluto's incredible story.